Hello, protocols, packets, and programs. It is the 9th month of the year, and riffing on the 9s of availability, every year has only one 9 of official cybersecurity awareness, and it's coming next month. Instead of the 9s of availability, what would the 9s of security awareness look like? 4 9s, as in 99.99% of lines of code in a repo are tested and secure? 5 9s as the percentage of apps supporting SSO or passkeys? Or no 9s, and we just keep counting to 10 in the hopes that one day code becomes better. Which means this week we go straight to the news and catch up on all the things. Count your 9s and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. In 2024, the future of identity, security, and digital transformation converges at Octane, hosted by Okta. On October 15th through 17th, join the brightest minds in tech and business in Las Vegas or online as they explore groundbreaking innovations and unveil the latest Okta solutions to keep your organization secure, connected, and ahead of the curve. Whether you're a developer, an IT or security leader, or a visionary, Octane is your gateway to transforming tomorrow, today. Security Weekly listeners only need to pay $100 for your full conference pass for Octane by using the discount code OKTNSC24 at securityweekly.com/Octane 2024 and can stream the event live on okta.com/Octane. That's OKTANE. Imperva, a Talos company, is the cybersecurity leader that helps organizations protect critical applications, APIs, and data anywhere, at scale, and with the highest ROI. With an integrated approach combining edge, application security, and data security, Imperva protects companies through all stages of their digital journey. Imperva Threat Research and their global intelligence community enable Imperva to stay ahead of the threat landscape and seamlessly integrate the latest security, privacy, and compliance expertise into their solutions. Start a free trial today at securityweekly.com/Imperva. 61%. That's how many U.S. businesses experienced a software supply chain attack in 2023, according to Gartner. This attack surface is constantly expanding. To secure your software supply chain, you first need to control it. JFrog offers an end-to-end platform that manages and controls the binaries and DevOps processes across the entire software development lifecycle. With JFrog, you can deliver trusted software with speed. Visit securityweekly.com/JFrog to learn more and take control of your software supply chain today. This is episode 298, recorded September 9th, 2024. I'm your host, Mike Shima, and I'm here with John Kinsella. Hello, John.
Mike, I'm still not used to September, and as everything needs to be upgraded and kept secure, my internet is being upgraded this morning, so hopefully I'm able to keep this connection through our podcast.
All right, we'll see whether your patience with my topics about refactoring, that's called foreshadowing, keeps you around, or if you just have to table flip and depart, saying it's your internet is down. We'll see.
Oh, did you say refactoring? I think I can't hear you. I think my connection's breaking.
Going through a tunnel. Where did that tunnel come from? But this is the fun that we have because there's news, and once again, there's always news. But John, this week, I actually did not grab a ton of individual vulnerabilities. A little bit more engineering themed, I think. Even though the first thing I want to talk about is a CVE in Rust, of all places. This is a security advisory for the standard library, in other words, for Rust's STL. And it's basically a fix for a fix from when they had a vulnerability when handling command line argument parsing on Windows. And what came to my mind here was a little bit less of blah, blah, blah. Yes, as always, you can have memory safety, but still have other types of vulnerabilities. I like to beat that drum. But you can also have just bad design, bad APIs, because here we have a behavior that can be surprising to users because Windows removes the trailing white space in periods when parsing file paths. And that's what they say, brought out this particular problem. So it comes to mind about exactly at what point do you normalize an input string and then start doing security analysis on it or security comparisons on it. And the reason I use that like normalization and security, this goes all the way back to things like the double decode, the 90s almost or early 2000s when there were .. or %5C, %2F that wasn't handled correctly or was handled differently by Windows in how they would say, here is a URL, here is a command line path. It doesn't look like it has a path traversal. Now we're going to unescape all the characters and voila, check it out. It's got a path traversal. So in my rambling traversal down this path of this particular CVE, it did make me just wonder, like when you talk to developers, for example, you're thinking about an API, how much do you think about this is an input that's slightly off? Do we reject it? Do we fix it up? Do we just strip it and enable the user to get done what we think they wanted to get done? Or should we just say, sorry, there's white space in here. This was bad. Try again.
That's a great question. You can go a few different ways on this, right? It's so for me, well, I can't say for me personally, so let me remove that statement and sort of go more general. In some cases, this will depend on, I'm presuming we're talking about APIs, so let's stick at that level. I mean, this is CLI, but something's calling in one way or another. An API, I mean, I guess you could call it CLI an API. I know it's a bit of a stretch, but depending on what that API is, the service that API is providing, is it, lemonade stand? Is it nuclear codes? Is it, how to take over a data center? That's sort of the first of like, what do you want to design instead of responsive? Like, how do you want to respond to that? Do you want to say, oh, it's a lemonade stand. They said they wanted a large, but we only have a 10 ounce. So, okay, well, we'll do that instead. Maybe, let the user know we're doing this choice for them and whatever, right? Treat it like that. Mm-hmm. I think, so where I'm going with this, I think it comes down to me, how do you handle it? A, obviously you need to recognize an issue. B, how do you handle it? And then C, how do you inform the caller? For those nuclear code ones, if you don't give me the exact right thing that I'm looking for, like one of maybe two options, big bomb or huge bomb, I'm going to not accept it. But then here's where the interesting part, at least for me, comes in. How do I respond back to the caller? Do I tell them, am I clear about it? Do I say, hey, I don't know this option. Here's the two options I know about. Do I say, hey, I don't know this option, go back to the manual? Or do I drop silently? There's reasons for all three of those, right? All three of those are going to have different levels of teeth gnashing by the caller when they are troubleshooting and they find something or nothing in their logs going like, what happened? So I think that's the interesting part about this to me is when you're at one of those conditions that don't meet something you're expecting, in something like this, like what they try to do is you could try to fix it and clean it up and do what you think is right. And you can't just return back to Windows and tell Windows, hey, I mean, you wouldn't be calling back to Windows. You'd be responding back to the user. So you could say, hey, Windows screwed this up. You need to use another operating system. That's probably not going to work.
Yes.
So I think what they're doing, I think, is right for a normal use case. But really the important part around this to me is making sure the developer who's using this understands. So like, if I'm got a CLI that we've written and we for some reason are running it on Windows and we run into this situation, as the author of that code, I would want to be aware of, this is handled differently on Windows because of X. And now we're getting, I mean, this is fairly sort of particularly weedy thing, but maybe it's something that developer needs to know about. So how do you inform them about that? Is that like in your Rust documentation? Is there something that pops in your whatever code editor you're using, or how do you get around and deal with that? I think that to me is sort of the interesting parts of this.
Yeah, and thank you for highlighting that aspect of, is this a 400 error HTTP series of errors? Is it a 500 series? Is it just something a not okay? It's not a 200, because I like what you're saying about informing the user. From a CLI perspective, I think the only thing I'd add is I do like Git's kind of feedback when you mistype a command. Is they can sort of say, oh, did you mean, git commit with 2 M's and you can't spell, Mike, or, git clone and et cetera. So these are hints about helping the user and understand and providing feedback, but people also have to see the feedback and read it.
Yeah, and one more thing on this. There's another aspect that I didn't really cover there. I mean, it's, again, sort of finicky, but it pops in my head. So I started talking about really security levels of the service which the API is fronting. The other aspect could also be performance. If you're a high-performance application, like super high performance, maybe you don't want to waste the cycles to send back a response, or the response you send back has to be like, 3 bytes or something small, just so it's not taking up space on the wire. So that might also factor in, like, how do you respond to this, or what do you do with it?
Yeah. Well, speaking of introducing nuance and how do you respond, you grabbed an article here about TSA and SSO downplay SQL injection vuln in vendor software. Tell us a little bit about this.
And we're going to now try and upplay it. Yeah, so earlier this summer, I think you had the source article. Was this from Black Hat? Probably was, right? I'm not going to look at it right now. But anyway, so earlier this summer, some researchers found that one of the software packages that TSA uses has a SQL injection vulnerability. So what's going on here? For those who've flown through an airport, you might see there's sometimes a separate line for, I think it's called KCN, known crew. It's basically the pilots and the flight crew, right? They've already been cleared and background checks and all that type of thing. So instead of standing in line with the rest of us commoners, they get to go straight to the plane and get their stuff going for their job. So that front is level 1, or probably level 2 or 3 of the security. The next thing in there is sometimes there's an extra space in that plane, either in the cockpit or a jump seat outside the cockpit. So if a pilots commute sometimes. So if a pilot is like, I don't know, maybe he lives in Seattle, but his job today is to fly from San Francisco to New York. So he's going to hop from Seattle down to SF and then take the other thing across country. How does he get there? If possible, they'll try to put him in one of these jump seats. So they have a software package which sort of allows managing that. Which plane has an open seat? When are they going and coming? How do you sign up for that type of thing? That's a software package which had this vulnerability in it. So what they found out is anyone could come along. I think it was authenticated, if I remember right. But either way, you get into the system and you could actually add people in. So, Mike, if you want the jump seat and I've already got access in there, I could go ahead and add you. And that's probably bypassing a few levels of authorization and authentication that's needed physically. So they reported this to the TSA, and the TSA's response was, our systems are secure. We've got multiple layers of security. That's some vendor software. We have nothing we can do about that. Period. Which I'd say probably not the best way to respond to something like this. It's we take your security seriously is usually the proper way to do this. I'm joking. But so that was the first part. And then word just sort of popped back up on my radar on the last week or so is CISA finally got around to responding to this with a quote. CISA is aware of vulnerabilities affecting software used by Flycast system. We are working with researchers and government agencies, blah, 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 on appropriate mitigation efforts. So they have not seen any exploitations to date. So it was big enough that it got them to actually come out and do a press release or responding to the media on this. But it's sort of one of those things, if you are back to actually think about it to the previous conversation around external APIs, to use that phrase. If you've got some sort of an API out to someone else, whether it's maybe it's just an API or it's an actual web service or some sort of service, you can't just sort of blow off and say, oh, that's not a problem in our software. It's like there's an ecosystem here, right? So that to me was the sort of I'll say offensive part of how they handled this. Somehow no one was hurt or harmed in the making of this, but yeah, it's if you're doing this type of thing, I don't want to say take it more seriously, but respond to it in a meaningful fashion, I guess.
Yeah, and as you mentioned, it was the authentication part was the actual initial SQL injection vulnerability. It was a classic or 1 = 1 type of bypass. And I think to me, it's hard for me to have too much additional depth on this because we don't know. And as an aside, I think often security industry or AppSec folks have trouble saying, I don't know about a topic. But here, the reason I'm bringing up I don't know is that there can be other processes in place that are backstopping this. There are human processes where this doesn't exactly get you immediate access to the cockpit of a commercial airliner, but it could be one of those small things that combined with other types of social engineering, bit of luck, who knows, could get you in there. So definitely not dismissing it, but saying it more of, I can imagine how there's processes. And I would love to know if, for example, if this were a bug bounty report from, at a company I worked with, we'd want to be able at least internally say, these are the dominoes that would have to fall for someone to actually get on that plane, as a crew member and into that jump seat. But, from a podcast host perspective, the way we get paid, we only fly business in our dreams. So that brings us to two vulnerabilities this week. I was going to shift a bit, as I foreshadowed, into a little bit more of the kind of security, but security and engineering. So one of the ones that I wanted to bring up is a very short article from Run Reveal titled, "We shipped SSO support in a day. How?" And the reason I brought this up is that, especially with October Cybersecurity Awareness Month, it's really easy for, admittedly me, other AppSec folks to say, support SSO, deploy MFA, just do this one thing, use passkeys, which I think are nice and good, but it perhaps does hand wave a bit over the engineering that actually has to go on behind the scenes to implement and support it. For those of you out there, probably also thinking of the SSO.tax website that's kind of beating the drum, if you will, about getting enterprise support level SaaS models is where my brain is trying to go, to support SSO for nominal cost, not having it be a tax in the sense of this is going to cost you so much more extra per user. It's just nominal. The idea here then, to pull it back to this article, they explained a little bit of the data model that they needed to support this, some of their default choices, default behaviors, meaning that if one person requires SSO for this workspace or this org, then it requires it for everyone, because you don't want these, one person is requiring SSO, but then somebody else could log in without SSO through stolen credentials, et cetera, et cetera, et cetera. So it was nice to see that little bit of acknowledgement of appreciation that they did make some trade-offs, that this possibly isn't the most, or I don't want to say the most robust version they could have created, because I'm not trying to cast aspersions on what their implementation, but there are other considerations that go into just saying, we support SSO. How do we model where a user belongs to? How do we model the org tenancy? These types of things. It gets into just organizing data as opposed to just writing code. So that was my pitch to the AppSec masses today, to build that appreciation of engineering that goes on behind the scenes. But when we say use SSO,
yeah, it's funny. So kudos for pulling this off in 8 hours. That's great. And kudos for everyone involved here who were able to allow them to do that. The blog post is interesting just to sort of get people to think through, as you're sort of describing, like, what does your org structure look like? If you're in a large corporation, pretty much almost everyone listening to this, you're not the one setting it. It's someone set this before, and that org structure exists, and ain't nobody going to change it anytime soon.
Yeah.
But for the small and medium-sized companies, like if you've never done this before, I remember at some point in my life reading and learning how to design an Active Directory tree structure. And like, if you're going to go do this, at some point you're going to waste a few hours trying to learn and head scratch and figure out and make sure you're doing it the right way, because you're usually only doing it once. So I'm glad that they covered that in there a little bit. But I was poking around the tool they're using, this SSO Ready folks, and it's hurting my brain that I don't understand. I mean, it's funny. I don't understand people giving something away for free. Says the guy who's done a bunch of open source stuff, right? But Yeah, so it seems like two guys got together and said, "Hey, we can make this easier," and they created this tool and they're giving it away for free. But I think I'm looking for, like, is there a consulting arm or something else going on? Like, they've got a company tab on their website, but it's like, yeah, it's free. We're the two guys who did it. So hey, cool. I mean, that's. I hope they support it and keep it going and doesn't have a vulnerability in a year or two, and we're back in that sort of situation again. But yeah, it seems like a neat little project.
Yeah, neat little project. And maybe it is that open source model where they provide the consulting, implementation support, that type of thing, and the code itself is out there for everyone to use. So fingers crossed. At this point, I do want to. We've got a couple other security related things, but I do want to take us we're going to take a detour, John, at the signpost up ahead to talk about a little bit more engineering and introduce Rust along the way too. But first, there's an article from the Pragmatic Engineer. Now, this is, for those of you who might be familiar, this is a subscription newsletter by Gurgly Orosz, which hopefully I got that pronunciation. Apologies in advance. But some of the articles are for free. This article is about paying down tech debt, and it's also written by a VC, former engineer. But I'm only saying that because hopefully this doesn't turn out to be a VC who likes to pay comedians to have a really good Twitter feed or just make pontifications rather than actually having something useful. But I thought there was something pretty useful here about paying down tech debt. And it goes through some strategies and some trade-offs about when tech debt was worthwhile to consider, to direct an engineering team to deal with. And one of the immediate benefits was, the theme was saying, want to show value, want to deliver value, whether that is value to a company, you're selling more widgets, et cetera, getting more signups, delivering value to your users, or in this case, delivering value to your developers. So the first example of tech debt was something that sounded actually pretty easy to clean up for their build system and their build environment for their code, which just made all the developers happier because you could build and test code more quickly. You could just see, it had a very tangible benefit. However, there's some other areas where it didn't make sense to go and refactor. But before I get into that, I want to throw it over to you, John, to get some of your initial reactions to this article.
No, I think this is really neat. My sense we've covered a few articles around tech debt over the years. And I think one of the things we sort of, at least day to day, we throw that phrase around, there's tech debt, someday we have to deal with that. Or it's sort of, that can tends to usually get kicked down the road until some senior engineer says, okay, I'm not doing anything else until we fix this. And okay, well, let's go fix it. Or someone gets bored on the weekend, right? That's usually the way we handle this, I think, as an industry. So I think it's neat. Of the sort of thought pieces that are out there, sort of, as you said, from that sort of VC-ish type space, VC/Eng, I think this is really neat for most managers to think about, like, hey, these are 5 ways you can think about how do you deal with this? Like, how can you not just schedule it and structure and put it into a Scrum or that type of thing or a sprint, but how do you actually figure out what sort of levers do you have out there to be able to get people to work on it or to make time to work on it? And I think that's really neat.
And one of what's neat about it too is it also highlights one of the honestly social, psychological, human reasons that people like to rewrite code or they worry about it, is that from Joel on Software. This is a good quote back from the 2000s that basically is, it's harder to read code than to write it. And there's other comments that we've seen before. People spend more time reading code typically than they do writing it. But a lot of times you as a general person can show up and say, oh, who was the idiot that wrote this code before me? I can do it better. And this is where you get into those ideas of let's rewrite, let's refactor. And what this is pointing out, sometimes you can do that. You can be overly optimistic about why you would need to do that and when you should do that. And uses a good example of talking about an iOS application that had some complex edge cases that they wanted to rewrite, refactor to make it pretty, make it clean, make it work better. But they realized, oh, we actually ended up spending a lot of time on stuff that we could have just addressed those edge cases and moved on to something new and different. So, yeah, that was a hard pill to swallow for me to read truth like that.
But again, I think, again, that's sort of what's neat about this is once you have sort of a structure of like, here's 5 ways you can deal with this. Then it turns into a conversation of like, okay, Mike, you want to refactor this. Beside the, when are we going to fit it into our time schedule with everything else going on? It's like, what's the trade-offs or is there a way we can, instead of having that sort of negative manager conversation of like, I know you want to refactor this into Rust, like everything else you've been talking about for the last 6 months. I've heard you already, Mike. We will get to it next summer when you should be on vacation, so you can work on this.
Yeah.
Instead, say, hey, okay, cool. This is something you want to refactor. Well, let's see. Is there something we can benefit from this? Like, okay, is there going to be a speed improvement, or is this going to help us work on something else down the road? Or I think I like it from that point of view also, that it sort of hopefully gets people into thinking. I think if a manager or even a developer, anyone, well, maybe not anyone, if folks in software development read this, it sort of primes the conversation a little bit of like, okay, hey, here's some ways that people have thought through doing this. How does this affect us or what we're working on in this particular situation?
Yeah, and there's another aspect too of this. It mentions testing throughout, and I do want listeners to remember about this. There's one comment in the article at Trello where the engineer worked. Adding unit tests to a code pace helped me finish a project faster. Which is, okay, that sounds like somebody's a manager hat on is trying to convince me to make more unit tests. I'm not dismissing it, but not everybody has that testing, and it doesn't always feel like you're moving faster when you're writing more tests. And I see you trying to get in there, John.
I don't know if I buy that, right? I mean, that's going to come down to, so there's two, I'll leave it just at 2 aspects on this. One is, okay, frequently when you go to write a unit test for a new part of code, it might not be a simple thing to test. So that's one thing that's not going to be faster. And the second, it feels like there's a bit of a false sense of security there that your tests are actually covering everything. And so that's also, I mean, maybe, it's very possible that it could be correct and that's accurate, but I would take that with a heavy grain of salt personally.
Take that with a grain of salt, because I'm used that in a sort of syncopation amongst all of our articles here. I've got a article from Google Security Blog about deploying Rust in firmware code bases. So this is a little bit of either rewriting or writing anew. So similar to that concept of tech debt that we were just covering. But there's a line from this article that says, when choosing a component to replace, focus on self-contained components, okay, with robust testing. Oh, that's sort of like, oh, right, you're kind of assuming that there's robust testing right there in the first place. And you set that up beautifully with the types of tests that, like, the questions you have about coverage, et cetera.
Yeah, it's, I think we could talk about this article for a while. Let's see. I think, it's, and then again, this is Google, right? So it's very easy for Google or other orgs with large, very well-defined software organizations, software practices in those organizations to say, oh, we've got the unit test covered, so we're able to do this, right? And that's from my previous statement about like, oh, I'd be sort of careful about this. This is a much stronger statement of like, we've got a very mature software development practice. We've been doing this for years. We know how to refactor. We know what we're doing. We've developed languages, right? Like they know what they're doing. They know they've got their test coverage. You have confidence in that test, in that unit test suite. So at that point, you have a lot more confidence to say, I'm going to, rewire this over a weekend, or I'm going to make a more drastic change and not have to be worrying about like, oh my God, am I going to break something, or is it going to break in like 3 weeks time when we put it in prod? So that sort of definitely affects you there. Quick sort of funny haha, maybe not funny haha, but to me, when I first saw this article, when I saw firmware, I'm like, it makes you think of like, when you think of an organization like Google, how do you think of them? I started thinking about Google Cloud. I'm like, wait, they're putting new firmware on their like their servers or network devices. I'm like, okay, that's sort of interesting. Like, oh no, Android, I forgot about that. So that was a second, just the quick aside. But then, like, as I was going through here, one of the things which I don't remember if we've talked about before, but when you start doing low-level code in Rust, and I ran into this last year when I was working with the ESP32s, you suddenly, in some cases, aren't able to use the standard library. So you have to go into this no STD version of the code, which means you're basically left by yourself to write a lot of those low-level helper things which you'd used to. So that's they spend some time talking about that in here, but that suddenly what becomes like, oh, I just need to write a few lines of Rust to get something to work. It's like, oh no, you have to go and like do a lot of the legwork behind it, and becomes a much bigger problem.
Yeah, and that was one of those things that I didn't appreciate enough thinking about the IoT space firmware. That, as you said, the article mentions that firmware doesn't necessarily, you can't assume you've got the full-blown operating system that can support the standard library that Rust is going to depend on. Ideally,
well, I don't know. I'm curious to see how you react to this. I would say this is a sign of there's a few signs of the immaturity of Rust. I think this is one of them. The other big one, which comes to me frequently, is the compile times, which we've talked about before. And in my previous life, I get to see them more frequently and teeth gnash because of them. You know, we've covered on here, you know, that the Rust developers getting burned out. Like there's a lot of things that are working and changing and trying to improve, but it does feel like there's a lot of these. I don't know if you call that an edge case, but like there's some rough edges on the language still, I think.
There are. And I think even Raspberry Pi, when we were talking about IoT a week or so ago with Patty, you know, Rust is not a, you know, first class support even on the Pi. And I think, you know, for as much as it's a hobbyist world, as well as Raspberry Pis have shown up in space as well on satellites and whatnot. So it's a bit more than hobbyists. But I think that just kind of supports your point there too. Also wanted, however, to use this as a chance to segue into an article that I can't believe I missed. But speaking of refactoring and writing things in Rust, you had something a little bit more surprising. I'm going to use that as one word for this article.
So I think we might have covered Jane Street in the past. So Jane Street is a really so I'll back up a tiny bit further. Proprietary trading organizations, or sometimes called prop desks in a larger, like a Goldman Sachs, are a group of individuals that their focus in life is to take existing cash, which a bank has, and try to make more money off that by doing proprietary internal trading. So they're not trading for their customers; they're trading internally. Jane Street has been around for a while, and they've sort of got that. They're one of those companies that goes looking for like smart CS PhDs or master students to bring in and start doing really amazing work in some of the stuff they're doing. For whatever reason, Jane Street loves OCaml. So, and then the third part before I talk about this actual thing, we're at that time of year now, you know, September, that schools are starting back up, which means summer internships are ending. And a lot of us large orgs we've had like, you know, our interns all summer and they've been doing their things. And now you get to see like, okay, what do they actually do? And, you know, send them back off on their way back to the holiday of classes in school. So this blog post is sort of talking about, hey, what did our interns do this year? I think they call it, what have the interns wrought, the 2024 edition. But, you know, as it talks through a few different things, one of the ones that caught my attention is, you know, as a prop or anyone doing like, you know, a lot of data work, right? People think pandas and Python and things like that. Obviously, I said OCaml. So what did the interns do is they took a library called Polaris, which was a Rust data frame library. And for folks who don't know, a data frame library, basically its purpose in life is to help you take data from a large CSV or some sort of external source and like get it into a structure that can be used for manipulation in memory. And so, yeah, they took Polaris and, or I guess it's Polars, and ported it to OCaml. And it was interesting to me to see that both that they did, and it sort of talks through a little bit about that process. But, you know, we're so much on here talking about moving things to Rust for reasons we think are valid and memory safety and things like that. And it's interesting to see someone go in the actual opposite direction, trying to like get something into a language which they want to use in house, and they don't want to support 5 or 6 different software languages. And I think that's a valid reason to do it. Just sort of interesting to see.
Yeah, and in addition to what languages are they supporting, there's also engineering decisions about performance, looking at very engineering driven decisions. This wasn't just can we do it because we like parentheses in OCaml. We want to do it because it's actually going to have a measurable benefit. And that's, as a fan of R, in between data frames and graphing, you can do a lot of fun stuff with data visualization in R. So this was fun to see, and see some dusting off some memories of OCaml and writing stuff in OCaml. So let's transition back out of just pure engineering thoughts, which I say pure engineering, but good engineering I think leads to good secure code. So that's why I wanted to go down that path. There is some other interesting engineering in RISC-V CPUs, and I have some thoughts on a cloud. But before we get to the cloud, let's get to the CPU. Tell us about RISC-V CPUs, John.
So, and this is the RISC-V part of this is sort of it's just the latest and greatest. So I'll back up and sort of tell the pre-story here. Linux operating system, most of you probably heard of it, has this thing called sysfs. I don't know how much the average user sort of explores sysfs, but basically under /sys on a Linux box, there's all these, directories and pipes and files that tie into the kernel to allow you to either modify or tune or to read configurations or status of things. So I hadn't heard about this one, but apparently there is /sys/devices/system/CPU/vulnerabilities, which, as you can probably guess, will tell you if there is a known vulnerability in the CPU you're using. And up to this point, they supported x86, 64-bit x86, ARM, and AArch64, which is sort of ARMy. 64-bit ARM. Until this point, they didn't have support for RISC-V. So what they've done in here is it'll both show you if your CPU has known vulnerabilities, but also if they've been patched or mitigated, which I think is pretty great, right? I think it's one of the things we've talked about on here a few times of like, okay, you've got a vulnerability on a Cisco switch or like on a Linux box, and like, okay, is my CPU one of the vulnerable ones? Is it been patched? Like, how do I know, right? Unless you have like, I would think some sort of third-party vulnerability scanner, and that could be open source or not. In a lot of these cases, you're left going like, what is this? So it looks like that directory I mentioned, or that path I mentioned, is a directory. So they show an example of files in there like meltdown, ret bleeds, spec store bypass, spectre v1 and v2. And then I'm guessing for each one of these is as you look at those files, they'll tell you what's in it. Like, are we good? Or it looks like it says not affected if it's not an issue. So I thought that was sort of neat, to see that both RISC-V, which I didn't answer your question. Originally, RISC-V is sort of an open source architecture. I think we talked about before. It's actually becoming very popular in China. People can figure out why, but so yeah, I thought that was interesting. They've added support for that in here, and that this thing exists in the first place. So
the thing exists, and what appealed to me about that, and which I also learned, I'll have to admit, about the sysfs on the Linux kernel, is that it provides that better, more confident observability. Am I vulnerable or not? It gives that type of feedback. And the reason I mentioned cloud is that a couple of weeks ago, Amazon announced too that they were also going to be talking about their cloud vulns, enumerating them, much like Azure did, much like a Cloud Vuln DB project that originated from Wiz was talking about. And the reason I'm pulling those out is these are often vulnerabilities within the service provider themselves that maybe don't have a CVE, and probably the service provider even cleaned up, but perhaps they only cleaned up for time 0 going forward. They didn't clean up any instances that might have been running at the time because they don't want to change behaviors on customers, et cetera, et cetera. Good legitimate reasons for that. But it's that idea of, oh, wait, am I impacted or not? Just seeing more visibility, being able to answer that question always seems appealing. So that put a smile on my face.
The parallels there are really interesting. Because in both cases, what you've got is you're using this thing which is sort of a black box. And a modern CPU is a pretty damn complex thing with firmware that in some cases you can't even get access to on some of the Intels, right? And it's the same with the cloud providers. Like, these things are massively complex. And you're just there like on a EC2 box or like a Lambda function, or I don't know what they call them over in Azure world, but like you're using this tiny little piece of it, and you've got the docs and you trust it, and it seems like it does what you want, but like, yeah, what is there, if we've got a suite of, I'm going to say AMD CPUs, I think is what Microsoft uses, Azure uses, is there whatever vulnerability, has that been patched on these or not? Or like, how do I tell? Or are we using an up-to-date version of Java? Or, we're talking about Rust, has that been patched in there somewhere in like their serverless code? So yeah, it's actually a significant issue.
Well, let's bring together now some of these concepts of security, firmware, and I will introduce one of my favorite areas, cryptography and side channels. So Yubikeys, everyone's been figuring out, do I care? How much do I care? Should I worry? Is the sky falling? The short answer is no, carry on. But there is a leak in the ECDSA implementation that is has an official name now called it's a takeoff of Euclid, so the EUCLEAK or EUCLEAK. This is what's the problem when you have to be a verbal podcast in audio rather than having to just let people read stuff. But in any case, there is a side channel that enables an attacker with physical access, what the authors describe as perhaps a few minutes of physical access in order to measure some the side channel. They can extract the secret portion of the DSA key. And in that case, once you have the secret portion, you can clone it. And it's that clonability that becomes, it's potentially not detectable because you don't have to destroy the key to look at this. And it just gets replayed. Now, part of the reason it's been downplayed is that the attacker cost here, or the attacker scenario that they can't pull this off en masse, so to speak. So I think that's a good thing, but but the other aspect of this is really interesting, that the vulnerability, as the researchers claim, went unnoticed for about 14 years, as well as a lot of common criteria certification validations. And you can, maybe there are different aspects about testing that we could get into too, about common criteria and robust testing or not. But the only last thing I had to add is that, as the researchers describe it, the vulnerability was due to a non-constant time modular inversion. And that's just going to be the name of my next prog rock band. So I had to throw that in there. Now over to you, John.
We were staying off air. I still think that's that's something from Star Trek. Yeah, when I saw this last week, I sort of want to grab a Yubikey and like actually play around with it, like spend a Saturday just see if I can reproduce this, but that requires time, and I haven't had a lot of that recently. It's. I think they found something really interesting. I don't know. So I haven't personally heard a response from Yubikey yet. I'm sure they know about it and they're like whatever they're doing, but like, I'm not aware of any companies that I've seen. I've asked a few folks out there around, poking around the last few days. I'm not aware of anyone just like replacing Yubikeys en masse. Like, as you said, it'd be a very targeted attack. And then the last point from me is they're still waiting for a CVE ID, which makes me think, Yubikeys not taking it very seriously? Or, I don't know. I thought that was interesting when I saw it at the bottom of the EUCLEAK webpage.
Yeah, I know that there's been there's been some background radiation within the AppSec world about the staffing and how lagging CVE ID and the CNAs are. And now I'm messing up on my terminology, but assigning and reviewing. So there might be an aspect of that, but it could very well much be exactly what you said exists. Where's the coordination for the stakeholders involved here?
Yeah, I'd expect that they wouldn't be getting that CVE directly from MITRE, and the other guys usually aren't too bad. But maybe they are, and it could be that. I'm not trying to throw shade at YubiKey. I'm just guessing right now. So, but yeah.
Well, if you want to continue to guess, you can ask an AI-based tool to help you out. Just say, "Hey, dear Claude or ChatGPT, help me summarize this article." Or you can also ask them, as maybe you would do. I hope not, John. But if you want to provision some cloud infrastructure, and what the folks over at Trail of Bits have demonstrated is that probably one amongst many examples is that ChatGPT, Claude, can possibly not give you the best recommendations on how to, set up the Terraform to define some infrastructure. And what they were pointing out is that it was the both of those cases were giving you some Terraform with some hard-coded credentials. I was just hoping for a bit more here, to be honest, from a Trail of Bits blog. It went on to a diversion about the password generation and hard-coded passwords, as opposed to good alternatives to say, don't hard-code the credentials within the Terraform itself. But nevertheless, obviously a fun article, informative article, and that's why I wanted to include it. But I guess maybe, John, I'm guessing you like your hand-crafted bespoke Terraform code, but maybe would you go to ChatGPT to choose a secure password for you?
Happily haven't written Terraform in 2 or 3 years.
Okay.
What I did do is, as you're giving that great description there, and I'm coming back to your answer in a second, is I asked Claude, hey, why doesn't EUCLEAK have a CVE ID yet? And while it didn't know anything about EUCLEAK, it did give me a pretty good reason why some things sometimes do or don't have CVE IDs. And I don't want this podcast to turn into so we asked the bot, but I just thought that was interesting. Oh, man. I'm hearing more and more. I would say it's somewhere between noise and conversation. It feels like I'll say the meat in these conversations is becoming, at least from in those circles which I hang out in, it's becoming a little more serious discussion around, hey, what do you use this thing for? When can you use it? Or shouldn't we be using that instead? And I think that's interesting conversations to have. In this particular case, it's funny. So I haven't written a line of code in, I don't know. No, it's not true. I've written some code, but I haven't really worked on a project in probably 6 months. And one of the things in my mind recently, we covered an article here 2-3 months ago of some guy who I think he had a kid and he was he's a busy father with a day job. And he was using one of the various different chatbots to help him write code so he could still do things and experiment, but not have to learn the programming language from scratch. So I can where I'm going is I'm trying to spit out of my mouth is I can see the value in using some of these things for something like that, versus learning Terraform. And I don't know if they figured out to add for loops yet. Last time I checked, they hadn't. I think they might have by now. And don't get me wrong, I'm not picking on that one. Most of those languages suck, if not all. I think what caught my interest when I was looking at this before, if I find the right tab, I don't need to, is, and we were talking again a little bit about this before we hit record. This article, it feels to me a little below what I'd expect from Trail of Bits. From the point of view, the passwords it gave them, they're not really random. Okay. There ain't a chance in hell anyone's going to crack one of those passwords anyway. So, correct, you're technically correct. They are not random. But if someone managed to just brute force or any other way one of those passwords, I'd be super amazed, right? I thought the code it generated was okay. It's not great. I think I wanted to look at the last example. I don't think I got to it. Oh, yes, right. The random generator looks like 20 lines to generate a password. And I thought what was interesting is, while this is talking in the title about provisioning cloud infrastructure, they're not really doing much cloud provisioning, right? It's there's a few samples of that at top, and then it goes in a completely different direction. We're both huge fans of Trail of Bits, so I'm not talking down. It's just I'd expect a little more meat than I got in this one. I think this is a perfectly great use for them, right? Particularly, just go back to the conversation we were having before about, Azure versus Google versus Oracle versus AWS. And Terraform is horrible at this, last I checked, because if you want to support multiple clouds, you have to have multiple versions of your code. You can't just, again, last time I tried it. So, hey, maybe I'm usually writing for Oracle. I'll pick on them for a change. And like, we've got our 1,000 lines of Terraform going there, and we've got a customer who wants to go run this over at Azure. Do I have to go through and troubleshoot that stuff all the time, or can I like paste that bad boy into one of these bots and say, hey, can you make this work in Azure for me? And then is it going to be, at that point, the question becomes, am I trusting it too much? Is it good enough, or is it going to get what I want done? And then I think that comes back to the user to be smart enough to go, hey, where are those places I need to look? Is it generating passwords? Is this example, is it setting up security groups right? Is it patching the machine? Is it using a modern version of an AMI or whatever you have? So I think that's, you have to have, I think it helps, but they're tools, right? They help. You can't just trust it blindly.
Can't trust them blindly. And yeah, the idea that are these tools saving time? I think that's what I see the positive feedback from engineers talking about it. In this case, the other thing I wanted to bring in, since we are coming up on the cybersecurity awareness month of October, the author does explain why, in this case, the password generator is not using cryptographically secure random seeds, and therefore you could enumerate all the passwords. But one of the things I wanted to point out is that you don't need to brute force the password these days if it's sitting in plain text in the Terraform, or even just the idea that yes, the Claude and ChatGPT both give like some suggestions for creating strong passwords, but that feels like the 1, maybe 2 decade old type of AppSec security awareness that we should be moving away from, in the sense of use a password manager, that all these things about the composition are predicated most of the time on somebody obtaining the hash and doing a brute force guess against the compromised hash. Whereas I would point out the brute forcing against an API, against, over a network, you're not getting your order of magnitude, the amount of guesses you get is much lower. It should be noisier, meaning it should be observable and detectable as well as blocked. And especially within the cloud world, there's secrets managers, whatever flavor it's called across them all, use a secrets manager. And so that's why I don't even want to pick on is it 12 to 16 characters, blah, 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 because that feels the wrong argument to be having, the wrong conversation to be having. And that's the other takeaway I wanted to pull from this.
Sort of related to that, like as you're saying there, I was really looking at the password generation code. And yeah, I think it's good enough, sorry. But I think what would be interesting here is like most of these the large ones that I know about, the OpenAIs and the Anthropics, all have the ability to, at least at the paid level, allow someone to customize that now, right? Use my corpus of data to actually train this thing, or to improve upon the results of the training. If it'd be very interesting to see, and if a company out there has done this, I'd really love to talk to you either on air or off, just to purely out of professional curiosity. Figure out like a corpus of, these are, if someone's using a password generator, this is what it should look like. If someone's using random generation, this is how you do random generation correct. Input filtering, all these sort of OSP top 10 things. My sense is those should be able to be coded for, or be used to improve the results from one of these systems. And I think that's going to be interesting. There's another one, I can't remember, I think it might be OpenAI, Mike. They're announcing the next version of their LLM. I think it's them, so apologies to everyone if I'm getting their company name wrong. But one of the ones out there is going to start using the LLM to generate code, not from everything else, but it's going to start generating code or whatever else it's using, and then using that to train itself. The purpose here being is there's a chance of poisoning happening with all the AI stuff going out on the internet, and you can't use that to now train yourself because you go get a cycle. So they're looking for ways to improve that. So maybe you actually have really good code going into this thing and then use that for training and then the results. So hopefully these things will improve.
Hopefully they will improve. And speaking of things that have improved, there's lots of things that also come back and haunt us forever, like the 90s. I have one last article here. Microsoft finally is getting rid of might be a little bit too strong, but they're at least disabling ActiveX by default. And ActiveX dates, that's technology all the way back to the 90s, which you can say is also a victim of its success, considering that it still is in a bunch of Office documents, although its use tends to be mostly phishing malware and, malicious delivery rather than doing fun financial modeling that people use OCaml for these days. But I had to mention that because while ActiveX is going away the 90s, Oasis is from the 90s is coming back. And if there's anything about choosing passwords, you could take some Oasis song titles, perhaps, as Champagne Supernova Wonderwall 1990 something would at least be a long, hard password to crack. So that's my parting thoughts on our news of the week here, John.
That was the correct password. You get to use the jump seat. So ActiveX was around for 20-ish years, let's call it. So that means we'll be talking in 20 years about
I know.
Microsoft removing JavaScript from Excel.
Oh, they just introduced it, last year. So who knows? Maybe it'll be, but WASM will save us. WASM compiled by Rust is going to save us all. Get that JavaScript in your Excel spreadsheets. Thank you for that fun reminder, John. And thank you again for walking us through a longer double segment, if you will, of news this week.
Yeah, it was fun.
I want to thank everyone else as well for joining us. Remember, please subscribe, share on the socials, check out the show notes. And speaking of drums and beats, check out Drip by Lucy in Disguise. We'll see you next time on Application Security Weekly.